That was the interconnect. And what are we going to use it for? Well, we want to use it for file shares. We want to do what we today would think that's insane. Running large SQL Server workloads on file shares doesn't make sense. But some things happened. For the first, we have increased stability, and we reached that by cleaning up the protocol. I've personally had analysis server cube processing a SQL Server data warehouse of 1.3 terabytes. Once it's finished, I started again. When it's finished, I started again. Once it's finished, I started again. And the SQL Server running over file share to a file server, and the analysis service on a third machine. I had that running 24 hours a day for almost 3 months with no outage at all on the networking level, on the storage level for the SQL Server. Then we got multi-channel and RDMA. Multi-channel I'll get back to. RDMA I already explained, and Microsoft's term for that is SMB Direct. And then we massively decreased the complexity. So if we go back to one of my initial slides with all the red boxes of the LUNs and the fabrics and the zoning and the storage array and the MPIO and all that stuff. Well, if our storage is just a file share, that means our SQL Server nodes just have what on the Windows CD, and then we install SQL. There are no shared components, there are no MPIO, there are no DSMs, there are no HBAs with queue depth and so on and so forth we need to consider. On the file servers, we have a few choices, but the important thing is, even though we do put DSMs on to access storage, we don't have SQL Server to take away all the CPU capacity. So we never get in a situation where, I mean, Thomas Kaiser and I did a solution a few years back where we actually did a denial of service attack on the clustering setup, because we did the queries and the database and the indexing right. So our queries ran all CPUs at 100%, and it did that for 19 minutes. But that means SQL Server didn't answer the clustering's heartbeat. So the heartbeat in the cluster manager said, I haven't got a response from SQL Server in a while. It must be dead. So it stopped the SQL Server instance, moved it to the other node, started again. But it was actually running just absolutely perfect because all CPUs were utilized. That kind of situation we won't run into if the storage subsystem and the clustering runs on a node where we don't run SQL, because we don't use the CPU capacity. So we basically split those two workloads across the network. And our border between those camps is the file share. So basically, if Windows can access the file share, it's not on the SQL node, it's on the file node and so on. It's very easy to figure out on which end do we have a problem. So, but all this requires the new SMB, the 3.0, and in order to do that, both the client, the SQL Server, and the backend file server would need to be Windows Server 2012. And one other interesting thing they did is that when you do file clustering today, you basically just say, I want to do a clustered file share, and you type in its name and which disk it's on, and you're finished. Now you get an option. There's a little dialog saying, do we want a traditional file share, or do we want this new type of continuous available file share? And if you choose that one, it goes into a mode where unplanned failures is actually supported. So imagine you have your SQL Server up here. It's doing I/O, let's say, to the transaction log, to a file share on FS1. FS1 is our virtual file server name. Then down here we have the actual physical nodes. And let's say node A runs this file share right now in the cluster. While this guy is doing traffic to the transaction log or data files or whatever, and it can be heavy traffic, I can pull the power plug to this file server, and this guy will resume the traffic to that file share within the timeout of one TCP/IP packet. So SQL Server will never realize that the server actually handling my I/O to that file share just died unplanned, because this guy resumes it immediately. And the reason for that is that maybe you've seen in 2008 R2 Windows, there's a disk type called a CSV, or clustered shared volume. That was made only with Hyper-V support, but in 2012 it's expanded to general usage. And the idea is that instead of traditional way of Windows doing clustering with storage, is that if we have a 2-node cluster, or for that matter a 16-node cluster, and we have a shared disk that all of the nodes can see, it's only online on one node at a time. And that means whenever we need to move from one node to the other, we need to stop all services using it, we need to dismount the disk, we need to mount it somewhere else, and then we can start and resume the services. On Windows 2012, they took a different approach when you choose this continuous available option, that it's online on all nodes at the same time. So all the nodes can actually see the LUN, and they can write and read from the LUN at the same time. They just internally coordinate who handles which requests. And that means because the file share is already online, the disk to that file share is already online. Resuming that traffic is a matter of just pinging the switches and updating the MAC address. And it can do that within the timeout. And that means you can pull the plug without no clean shutdown and while it's doing traffic. And your SQL Server will not put your databases in suspect mode because all of a sudden I can't do I/O to the data file or the transaction log. So that actually means we can do more high availability in some expensive storage arrays, because we will have a small outage when we move cluster nodes or data centers or something. Here they're online at the same time. So multi-channel. Well, we discussed copying a file over the network, thinking we would do 100 megabytes a second, but we would do 20 megabytes a second. The new thing is that it opens multiple lanes, as we do in PCI or InfiniBand, that whenever, let's say one lane can handle these 25 megabytes a second, when that's not enough and the application still pushes, say, I actually have more to give you, it will open another lane and another lane and another lane, and it can open up to 8 lanes on one NIC automatically. It's nothing you need to do anything about. And we have various scenarios where we have one NIC, we have multiple NICs, we have teaming NICs, we have InfiniBand. So going through them, the third thing is that today actually a 10 gigabit link is one thread, meaning one core, and it's actually pinned to the core, so we can, with 10 gigabit we can actually saturate that core 100%. And since our CPUs in megahertz tends to get slower, well, the likelihood of pegging a CPU core is much bigger if you don't do something about it. In 2012, since we open multiple lanes, we actually also redistribute them across all available CPU capacity. So we won't see one core go to 100% and be the bottleneck of our networking bandwidth. The requirement is that the NICs are RSS capable, receive side scaling, or basically, if you go to properties in a network card and you have all these offload this and offload that, that's RSS features. But let's say any server NIC produced in the last 4 or 5 years are RSS capable. Another situation is, what if we have multiple NICs? Well, what happens is, initially we start out here on the client, let's say that's a SQL server, and here we have the file server. So we start one lane on one NIC. This is the one that's routable, this is the one that connects to the internet and talks to everything. These guys here can actually just have an IP address on a completely separate VLAN. It doesn't have to have communications with the rest. So the SMB client starts and asks the server saying, hey, by the way, by any chance, are you an SMB3 client? Yes, I am. Wow, good, I am too. So give me a list of all your NICs and all their capabilities. So the server sends a list of all the NICs and the capabilities of the client. And it will realize that, we have 2 10 gigabit NICs. For this to work, it has to be the same speed, and Windows will choose the NICs with the highest speed to run the data across. So they are equal, and this NIC is connected to that NIC, this NIC is connected to that NIC. We don't have to have cross connectivity. So it will say, well, I can utilize that bandwidth. So it will open up as many lanes as possible and redistribute them across all the NICs we have. So if we have 4 NICs, we would have 2 on each of those 4. If one NIC falls out, it will move those lanes and redistribute them on the leftovers, again without any outage. If they're not RSS capable, the same will start. It will get the list of NICs, but it will not open multiple lanes. Multiple lanes requires RSS. But again, not important. I don't think you have servers where you would do this kind of setup that has NICs that are not RSS capable. And the good thing is, because it automatically does this, it actually has linear scale. So these are some measurements actually done on the beta of the Windows 8 kernel. So we see 1 NIC, 2 NICs, 3 NICs, 4 NICs, no teaming, no nothing. Just put in the servers, be able to ping, no gateways, no nothing. And you see above a gigabyte, above 2 gigabytes, above 3 gigabytes, and above 4 gigabytes. Linear scale. So again, going back to our SQL Server needs massive bandwidth. It's very, very difficult to increase bandwidth, but on this kind of technology, just once it's configured, plug in a card every time you have saturated your bandwidth. We don't need to buy all new components, we don't need to reinvest, we don't need to do a technology shift. It's a platform where we just add as we go. So start out right, and then just add in cards. I think it's very rare in this industry that we see linear scale just by adding new devices. So how does RDMA work? Well, the application SQL Server wants to start communication. Then the SMB client figures out that communication we just talked about, that the other guy over here is also SMB3, and he has RDMA capable NICs. So he will actually bypass NTOS kernel in the TCP/IP stack, move to a non-standard protocol. It's not TCP/IP traffic, so it's not routable, by the way. They need to be in the same switch. And then this guy can actually go to this RDMA capable NIC and access something on that server, bypassing the traditional operating system stack. So imagine over here we had a Fusionio card, and here we had SQL Server, and that might be a cluster of 2 SQL servers. Then those 2 would talk SMB direct to the RDMA NIC, go to this storage server and access the Fusionio. But all of a sudden 2 servers can access a Fusionio card, which is normally direct attached storage inside of one of the servers. So we just effectively converted direct attached storage to shared storage. Running InfiniBand, it has so low latency that accessing it over here has the same latency as accessing it locally.
Question about the reliability about that scenario.
Mm-hmm.
I mean, package drops and that kind of things. How rare is that kind of things?
But that's what I said. I had an analysis services queue processing a 1.3 terabyte warehouse for 3 months in a row, and it just did 24/7, no outage at all.
Okay, yeah.
So, and Microsoft did the same, just for much longer.
Yeah.
And again, we have multiple cards, we have multiple lanes, and cards can drop out, lanes can drop out, and it will just move the traffic to whatever is available. And actually, now that you ask, once we go to InfiniBand, well, it starts with normal SMB traffic, which is port 445 TCP. Once it realizes that it's RDMA capable InfiniBand NICs, it will enable those fat pipes of 56 gigabytes a second. But it will keep alive the traditional SMB port. It's just waiting. So should some of this actually fail for some reason, it can fail back to this guy, but if the entire InfiniBand protocol fails, it will fall back and reopen this one. It will run slow, but it will run on the SMB link. And once we re-enable it, it will realize it, and then you start using the bandwidth again. So it's very, very automatic. And the reason they are drawn in red is because it's not TCP, it's not routable. It's a proprietary InfiniBand protocol. So you can't firewall it, you can't do anything. But since you can't route it, firewalls are not really necessary. So if we can start taking storage that are not shared and convert it to shared storage by ourselves with standard off-the-shelf components, we can do some new interesting designs for SQL Server setup. So the first one could be a SQL cluster, 2 or more nodes, have a file server, and in that file server we could put Fusionio card, which is solid state. We could put traditional mechanical disks and say this is our tier 1 or tier 0 storage. Here we have a tier 2 or 3, our archive. So this is transaction log, this is tempdb. We have designs where we, because tempdb can now be local, where we put a Fusionio card locally in each of the servers where we run tempdb. Then we run the transaction log down here. We run the active file groups, data files here. And then we do the less active or archive file groups on traditional storage. And then we expose it as file shares. And doing it that way, it's very flexible. So first of all, one very interesting characteristic of NAND flash storage is that random I/O is as efficient as sequential I/O. And do you know about NAND flash erase cycles, that once you have written it or actually erased it enough times, it will burn out? Most of you know that? Yeah. So in order for, imagine a database page on a NAND flash device, the header, that cell in the NAND flash would probably burn out a lot faster than all the data pages, because whatever you access inside the data file, you would always access the header. So all I/O coming to a NAND flash device comes in, looks at it, says, well, currently I reside in, let's say, cell number 57, but it's been erased 298 times. I have another cell which has fewer erase cycles. So instead of just writing that 1 kilobyte, I will read the entire 4 megabyte cell, merge the changes and write it to a different cell and not erase it. Just leave it until I actually need it. So the NAND flash storage will convert random sequential I/O to random on disk, but it will also fragment it 100% if you look at the structure inside of it. And because it does that, all of a sudden, all our management of storage saying, well, we have a storage array with 40 drives. We need to take these 8 out and make them to the transaction log, for example. Because then we can do sequential I/O to those 8 disks and for the transaction log, and I/O to the rest will not hinder the performance of that. Then we take out another set of drives and do a run on that for the data files, and another set for this and another set for that, and you start slicing and converting, and all of a sudden you will probably end up in a situation where I need 100 gig more on my transaction log run, but I don't have any more space. Whereas on my data LAN, I have 500 gig too much, but I can't reclaim it and put it in the other. It's a massive headache of trying to administer and try to predict in what way will our storage needs change over time. What if we have a storage subsystem where we don't have to do that? We just take all available space in one LAN. Imagine a storage array with 1,000 disks and just say, one array, 1,000 disk, one drive, that's a P drive, all storage in one. You would never do that because it will perform horrible. But on NAND flash, it's a completely different story. It doesn't matter. So we create one LAN for this guy. Then we just create, whenever we need a new application, a new database, a new instance, a new whatever, we'll just create a folder, right click it and share it. And then when we install that new instance, it will be file server 1 / folder 17, for example. But that also means that since it's not drive 17 and drive 17 become full, it's just folder 17, and the entire space is available for all of them. So it doesn't matter which instance or which database or which log or data file grows, because it's a shared storage area. We never need to reconfigure our storage space. It's only every half year, a year, when we get full, we buy an extra set. And then comes in a new thing that is also handy about file shares. So when I do a setup like this, I usually create too many file shares. So I could just do one file share. SQL instance 4, and then put transaction log, data files, everything in folders below that one share. But if I do a lot of shares, imagine when I get full and buy extra space, all I have to do is stop the instance, point the share to the new disk, move the files, and now I have space both places and start SQL Server again. No need of detach the database or however, but the point is SQL Server logically points to the same thing. Down here it's just a matter of moving files and changing the pointers for file shares. So management of storage, shared storage, all of a sudden becomes folders and shares. And I think most IT departments can handle that. And I would say a lot of the solutions, and some of you have probably also been in that case, where you or the business users buy this BI solution, special server, special storage, and then a week before it arrives, they go down to IT and say, oh, by the way, we bought this box and you need to own it. And they don't know how to store it, they don't know how to operate it, they don't know how to configure it. But a system like this, where we just enable all stores in one run, and the daily maintenance, the daily operations is creating directories and sharing them. That's really easy and doesn't introduce the need for new education or new procedures or anything.
Yes, again, how did you achieve redundancy in a solution like that? If that file server crashed, do you have another file server?
Then we have a setup like this. So I just heard in the break that some didn't know what Fusionio was. So Fusionio, imagine that red drawing with all the boxes. We had the LUNs, the disks out here, and we had all these kinds of steps, SCSI channels, backplanes, cables, fiber channel adapters, and so on. All that legacy interconnect doesn't really make sense in a NAND flash world. So what Fusionio did was say, instead of taking the NAND flash chip, putting a NAND flash controller behind a SAS controller, behind a cable, behind a RAID controller, behind a PCI slot, well, why not just take the PCI slot part and the NAND flash chip and glue them together and get rid of everything in the middle? That's really, really fast and really, really lean. That's what Fusionio pioneered. Today, other companies does cards like this, but they invented that thing. For shared storage, new companies like Violin Memory and there are others in that space has basically taken the same approach, saying, well, even for shared storage, there's no reason for traditional backplanes or traditional everything. You saw the performance load on the EMC symmetric VMAX before, that the NAND flash arrays were just as highly loaded as the normal mechanical arrays. And usually because of all that legacy interconnect, Violin Memory stripped away everything and said, well, instead of taking a NAND flash chip and putting on a PCI bridge, let's take a NAND flash chip and putting on the end of a gateway that could do either fiber channel, InfiniBand, or something directly out of the box. So we take a lot of this stuff out of the equation. So to do the high available one, where we do the continuous available file shares, that if we do unplug the power from one, this one will resume it with no outage up here. We have the requirement of shared storage on the file server level. But this still means that what we're used to install, the DSMs, the MPIO algorithms and stuff like this, is located only down here. We don't infest our SQL Server cluster with that third-party stuff. So here we have what's on the Windows disk and what's on the SQL disk and nothing else. Here we have what's on the Windows disk and maybe a DSM for the storage level and nothing else. For example, Violin Memory only uses the built-in MPIO driver in Windows. So nothing but what's on the Windows CD is here. So regression testing, complexity is low, availability is high, and simplicity is key. Then we could use our traditional storage arrays that you probably already have for, again, do some file groups for tier 2 storage or archiving or less access data, and then put your transaction logs and so on, high available hotspot data on the NAND flash shared storage. But again, whether it's that kind of storage or this kind of storage, the exposure to the SQL cluster is still the same, it's just a file share. But here we can live with one of these going out, and we can handle one of those going out. And in this layer, you can do synchronous replication or whatever, like traditional. There's no limitations. If the storage array you're using today can do a mirror between two storage arrays, or however you copy your data, you can still do that. There's actually a new feature in Windows Server 2012 called storage spaces, which will probably be worth a separate topic one day. There are some limitations in the release right now. We're trying to get Microsoft to understand why we need just a few limitations removed, but that's basically software-based mirroring. So a device like Violin Memory that doesn't do synchronous mirroring, we can do it in software.
In Windows?
Yeah. So storage spaces is that feature we use for that, but it has some annoying limitations currently. It works, but it's not supported. But this one takes care of your single point of failure. Yeah. So do your traditional replication down here, 2 or more here, 2 or more here. Here I would have loved to do a demo, but as the demo guards will, something's wrong with the SQL Server node, but I can show you just a little bit of what it looks like. If we start by looking at the server, this server has 2 Fusionio drivers. And if I go into it, I have just created a folder called SQL, and I have my SQL instances, and behind the instances I have my data files, transaction log, and system databases. And if I move into them, I just see all, and here you actually see file 1, 3, 5, and 7. Have you had a discussion about files and number of files and file groups in your...
Yes, we have had presentations around that.
Okay, because that's also a black belt topic. And lots of faith and beliefs in that area, but it's actually very simple with the facts. But when you do it right, you have 8 data files at least in a database, and because we have 2 Fusionio cards, we separate half the files on one card and half the files on the other card. So you see all the odd numbered on one, and you see all the even numbers on the other. Here. And the way we expose that, if we go to the SQL Server, and move the SQL Server to the screen that you can see. Okay. Let's take this one. So what you can see is that our master database is on a file share. Then we have tempdb, because I have lots of CPUs, I have lots of tempdb, but that's a local path. So the Y drive is a local Fusionio card on each SQL Server node. And then once we get past all the tempdb stuff, if we take the right scroll bar somewhere, maybe this one. Yeah, you can start seeing that all our user database, all our files are all placed on UNC paths. So and then somewhere we would hit the resource database, but that's local anyway in a cluster. So every single database, including system databases, are all on file shares, and then tempdb is on a local path. Yeah.
Would it make a difference if I created the tempdb on the local share on the server and created like a UNC path?
No. No. You just actually run a little bit through the network redirector, so you probably lower performance. And it wouldn't work actually. because the way RDMA and all this is done, it doesn't work over localhost as an address. So you can't. So somebody could say, why not just move the storage layer up onto the SQL nodes and have them use themselves as file shares? But that's not supported because the network redirector locally does some strange things. So we have to do it over the network. And if we go and see hit the right pixel in there. Oh, that's not one. This one. You can see here's my file server. So I basically created my instance name and my system databases, instance name, user databases, LON1, LON2 for the split, backup, transaction logs, and so on. It's just one drive, or two drives in this particular instance, but I create a lot of shares because this amount of shares will make it very, very easy for my IT department at a later stage to add storage, to add different tiers at the file server levels. Just repoint the file shares and we're good to go. I can, if I don't have SQL knowledge, I can just stop the SQL Server service, reconfigure the file server, make sure that I have the same shares when I'm finished, start SQL Server again. I don't think an IT department has ever had easier reconfiguration of storage for SQL Server. And you don't need SQL Server knowledge, you don't need SQL Server access, you don't need anything. It's very, very clean, very, very simple. Now I would have liked to show you the performance you can get out of this. But unfortunately, this particular setup has a problem with the link on the SQL servers. But just for those of you that haven't worked with NAND flash before, I will show you the performance you can get out of it. So I have Iometer. Do you know Iometer? Iometer is an open source tool to do I/O, and since it's open source and it's out there, it's industry accepted. Most storage vendors doesn't complain about using it. But if you look at these numbers, I have 20 workers configured. Each of those workers access both my Fusionio drives. I just made a 40 gigabyte file and put 12 outstanding IOs in the queue for each worker. My pattern I put on it is 8 kilobyte sequential reads, and what I get out of it is 306,000 IOPS, 2.4 gigabytes a second. And it's a card that costs 70,000-80,000 Danish. So try and go to your traditional storage array and say, we want 300,000 IOPS, 2.5 gigabytes a second, and we will spend less than 100,000 Swedish. I would believe they would start laughing at you.
So is it Fusionio, the driver 2 card?
This is the second generation card.
Yeah, second generation,
yeah. So that's important differentiation. So they made it really difficult to understand because they have Duo cards, and they have Gen 2 cards, and they have Gen 2 Duo cards. So what happens is when the cards go really big, if you look at them on a picture, it actually looks like two Fusionio cards glued together, which is exactly what it is. So they put a PCI bridge and two cards in one slot. So they actually exposes itself as two different Fusionio cards, even though it's physically one thing. That's the Duo cards. The Gen 2 cards are the second generation, which are much faster than the previous one. But I've seen customers buying the Duo, it's something with 2, and they get those, and it's the old one, and it's still good performance though, but it's not as good as the Gen 2 ones. So Gen 2 and Duo is very much different. But I think these numbers pretty much speaks for themselves. And what I would have showed you was two things. One thing was that the latency, I mean average 1.5 milliseconds. I'm guessing when you look at SQL Server, you probably see much higher latencies normally. But on the SQL Server node, we would see the same low latencies. We would see the same throughput. We would see the same IOPS because we do RDMA, and we're in the microseconds as we explained earlier. So whether that Fusionio card sits remote or local, we get the same performance. But all of a sudden now I can put it in a file server, I can do a SQL cluster and put my cluster things. That SQL server I just showed you was a clustered SQL server. So actually it's pretty funny to go in to look at the cluster manager. If we can hit, whoever invented that you need to hit that one pixel to get, should be fired. But when you see the cluster roles, let's take the SQL cluster. So this is the file cluster. Down here we have the SQL cluster. I have all my SQL instances, and if I look at just one of them, you will see it is very simple. It just consists of a network name, an IP address, the SQL Server service, and the SQL agent. Normally you would see cluster extensions and LUNs and disks and everything. It's all gone because it's not part of the cluster. We just point everything to our UNC path. But another thing that happens, which is when I saw it the first time, I think something must be wrong. And I discussed it with the product team. And they thought something must be wrong. And we dug a little deeper and we found out nothing's wrong. That when we run it remotely, when the SQL Server accesses this card, whether it's normal storage or Fusionio or whatever, viral memory, it doesn't matter. When you access the storage locally, I get one performance. Let's say these numbers. When I go across the network and access the same card over a file share and introduce two servers, switches, cables and everything, it's faster. I would have expected a little drop in performance because we have more components. But it turns out that the network redirector in Windows actually had an old feature that nobody ever tweaked because it was working as it should. Because we used to be in a world where we had, I don't remember the numbers actually, was it 10 megabit, I think, coax cabling and novel networks and stuff like that. And back then they thought, in order to utilize bandwidth, we need to collect them up the packets and burst them in large chunks. And it still does that. Whereas NTFS, the driver subsystem and the storage subsystem Windows, doesn't do any bursting and collection of I/O. It just says if an I/O comes in, I issue an I/O to the storage subsystem. If a new one comes in, I issue that. Imagine there's probably more overhead if they are different places than having somebody collect them and burst them. And that's actually the reason why it's faster. And we see on one of my machines, I do 1.7 gigabytes a second locally on a Fusionio card. Remotely, I do 2.2 gigabytes a second. That's 30% almost extra performance of introducing the file server. Just because now we get the network redirector who collects data and bursts them. So we have a suggestion for Windows Blue or 9 or whatever it will be, that maybe the storage subsystem Windows should look a little bit at what the network redirector does, because it doesn't make sense that I can access a disk or a file share remotely faster than on the local file server itself. But that is actually the truth. So a little bit of magic that's not so magic when we figured out what on earth was going on. So pretty sure something's broken. The performance counters doesn't work, there's something wrong.
What if you want a file share locally? How does it work then?
It's not supported. So all this SMB stuff, or the RDMA and SMB direct and multi-channel doesn't work with localhost as a connection. Another thing they did, I don't know if any of you use Performance Monitor, but it's a brilliant tool for Insight, but it's a hideous tool. It hasn't seen any love for a long time. And actually now the numbers are so high with these new kinds of storage. It was actually Thomas Kaiser who had a problem where he thought something's really wrong because the numbers we see just doesn't make sense. They're too low. But what got through was high enough. And it turns out that when these numbers of how many megabytes and IOs per second turns really high, there was a truncation problem. But they truncated from this side in. So looking at now saying 200,000, it should be over 1 million. But that's because it truncated the first or the last digit, depending on how you look at it. And so that was when he was still at Microsoft. He's actually working for Fusionio now. But he found out the guy who owns that counter inside of Performance Manager. And he just looked at him like he was a moron and thinking, is anybody using it? So maybe there's a reason why Performance Manager looks almost the same as it did in Windows NT 3.1 back in 1993. Is anybody using it? If the program manager who owns the feature thinks nobody uses it, nobody fixes it. But if you look at the disk counters, you have something like bytes per second, we have IOs per second, we have average somewhere, disk second from read, so latency and so on. Nice counters to get a feeling for it. If you look at networking counters, it was the networking counters in Windows 2008 R2 and back are just insane. They don't make sense. So they deleted all of them and created a new set of counters. And they modeled them based on the logical disk counters. So we now have SMB client shares, for that would be the SQL side, and we have SMB server sessions or server shares, that would be from the file server side. And since we're on the file server, we could open this, and I will get all my file shares. And here I have all my SQL ones. I'll just select a few. And if you look at those, compared to the disk counters, all of a sudden they look very much alike. Average second for write, average second for read, disk bytes per second, disk bytes per read, and so on and so forth. So basically remodeled and say, well, whether it's a local disk or file share, it's the same, it's storage. So on Earth, don't we have the same counters to monitor what's going on?
Michael?
Yeah?
We're now reached, we're now after 4 p.m.
Okay.
So I think that we can round off, and then you can continue showing things if anybody wants to stay, and if you have questions.
Can I do just 5 minutes quickly about Hyper-V? Or is that?
Well,
it's 4 slides and.
4 slides. Okay. Yeah. Very quick.
Because that was the last thing I wanted to. If we can find it there. So I worked with that storage team for 2 years about all the SMB and stuff. But also I was, as I said in the beginning, hired by the SQL team to be the liaison into Hyper-V. Virtualizing SQL Server. We usually don't have many CPUs, we usually don't have enough memory, and storage is really slow. So virtualizing big SQL servers was a problem. But Hyper-V version 3 had 2 goals. Adopt new technologies in Win8 kernel, like the SMB and RDMA and all that stuff, and be the best hypervisor for SQL Server. So how do we become the best hypervisor for SQL Server? Well, my previous company, we did a BI solution for IT, where we managed 13,000 servers each night, where we looked at data. Instead of asking an economic system or a customer, client, or tables or sources and so on for BI, we ask servers, how much memory do I have, what kind of OS, which patches have you installed and so on. And the distribution we got about CPUs was something like this, based on 13,000 servers, and that's why Microsoft said, well, we can already in Hyper-V version 2 do 4 CPUs, and that takes care of the grunt of it, so there's no reason to go any higher. Maybe go to 8. But then we came in some statistics saying, well, out of our 13,000 servers we watched every night, 1,500 of them run SQL. We have a very different distribution for CPUs. And these are more modern servers, so we have many cores also. So that actually helped them increase something. The next thing was that even though that was the case, they said, well, the majority of servers, if we virtualize them quickly, we can do that. But they would look at one server, can we virtualize it? Yes. Number 2, yes. 3, and so on. But that means if we had 750 SQL servers when we're finished, we have more than 750, because now we have 750 virtual servers plus the virtualization hosts. The right way of doing consolidation, and I'm guessing some of you probably did that, say, let's take a few large ones with some instances and then move all our databases to those few instances. That's what makes sense. But that means these big instances really need much more capacity. And we will also save space in that process. And that's the same statistics we pulled out of it, because it turned out for 750 instances of SQL Server, 37% were system databases. So if we cut away 750 times MSDB, model, master, and so on, we actually saved a lot of storage for a particular client. Next thing is looking inside of allocated space on the SAN array, used space by SQL Server data files, and used space inside of the data files. Out of 10,000 databases and of 1,500 servers, 83% is empty space seen from the SAN. But we can't reclaim it. We could if we did a SMB setup. So what we ended up with is some interesting numbers saying that Hyper-V went from 4 virtual CPUs to 64, from 64 gigabyte to 1 terabyte for each virtual machine. And then the physical host supports 320 processors. It was actually 640 just before release, but Intel is late with the CPU, so there was no machines available. If you do some numbers on 320, say disable hyperthreading, that's 160. 10 cores is the biggest CPU you can get, that's 16 sockets. So I don't know if any of you knows of a 16 socket server right now, but if you Google HP and Dragonhawk, some non-disclosure information slipped to the internet, and you'll get an idea of what's coming after the summer vacation. Maybe HP will announce something here in the conference in June, because they're coming out with a really interesting box for SQL and Hyper-V. So the last thing we need in virtualization is IOPS. Just before Windows officially was released numbers at TechEd in Orlando last summer, VMware went out with 300,000 IOPS a second on a VM. Hideously expensive, because you need the biggest licenses, and the hardware setup they did was really big. But on the beta of Windows 2012, we reached almost 1 million IOPS on Windows Server 2012. So those are actually some pretty good numbers, saying 64 CPUs, a terabyte of memory, and 1 million IOPS. I can think of very few of my customers that can't live within those constraints. So going back to this drawing, if we put Hyper-V below SQL Server up here, it gives us a new benefit, because when we cluster SQL Server, it's just shared storage clustering. So if I want to move SQL Server from one node to another physical node, I need to stop it and start it somewhere else, meaning all my running transactions are cancelled and recovery, roll forward and back. But Hyper-V does shared memory clustering. So I can take a running SQL Server and move it while it's active from one physical node to another. So down here I now have unplanned failure support. I can just pull the power cord, and I/O will be resumed. Nothing will be experienced from SQL Server. And with Hyper-V here in that layer, I can now also move my SQL servers between physical servers with no outage. So Hyper-V can actually introduce a new layer of availability it could also do that on 2008 R2, but with 64 gigs of memory and 4 CPUs. Now we can do 64 CPUs and a terabyte. So yeah. So that was quickly about Hyper-V. Also is very interesting in SQL Server terms. Finally. Yeah. That was.
So thanks really very much, Michael.
Yeah.